In this review, we'll take a look at charges and interactions, otherwise known as electrostatics. Here's an example of just a single positive charge sitting in the middle of nowhere. When another positive charge is brought near that one, you can see that the two charges will repel each other because they have the same kind of charge. Both are positive. In this demonstration, we're only looking at the force on one of the two charges, although that force would also be the same on the red charge here. Notice that the direction of that force, because it's a repulsion here, is always along the line that connects the two charges, so it would be this direction. If I move it over here, you can see again along the line between the two charges in that direction. You can also see that that force depends on how close the charges are together. The closer they are, right, the smaller the distance, the larger the force. That's going to tell us that there's some sort of inverse relationship between the distance and the force. The other thing that we'll see too is that that force depends on how much charge is actually present. If we were to bring in a second charge, notice that that force is going to be twice as big. Right? If we brought in a third charge, it would now be 3 times as big. Right? And if these were all right on top of each other, this would be all in a single direction. Let's take a look at the mathematics that tells us about how big this force actually is. The model that tells us how big the force is Coulomb's law. And that is that the size of the force, or interaction between the two charges, is a product of a constant times the product of the two charges themselves. And it's inversely related to the distance between the two charges squared. So in this case, this one might be Q1. This other charge might be Q2, and R would be maybe the distance between the two charges. Here's a case where I've drawn a couple of pictures. And if we were to call this R, or the distance between the two charges, here at the top, maybe that's twice as much distance. Notice that the force is sizably smaller. And that distance is actually multiplied by, well, twice as much. The force is not just 1/2 of the original value. Right? Because this is an exponential function or an inverse square law, when that radius becomes twice as much as it was before, the force actually becomes 1/4 of its original value.